Okay, so today is January 9th, 2011. We're on lesson 8.1. 2012. Whoops. Lesson 8.1. We're going to be using sine law. Okay? This is a brand new law to you guys. Now, before we were using trig ratios, they were for only what type of triangle? Anyone remember? Right angle, that's right. These ones worked with right angle triangles. This is when we're using acute angled triangles. So it's not a right angled triangle. Also, none of the angle sides are really obtuse either in these. So all the questions you have will have acute angled triangles. We're going to be using our sine law here. Okay? This is the law you guys are going to have to memorize for the test. The law says sine A divided by side B is equal to sine B divided by B is equal to sine C divided by C. We're going to make sense of all this. In the last chapter, I told you guys that it was important to know how to name a triangle. You can name it any way you like. There was one important rule that had to do with the angle in the side. Does anyone remember it? If I were to call this angle A, what side is side A? Opposite. That's very important. In order to set up sine law properly, you have to name the triangle properly. So the opposite side is side A. We use lowercase for the side and uppercase for the angle. Okay? Now, I can choose to call either of these side B. Once I call it side B, though, where would my, angle B, where would my side B be? The opposite side. Okay? And by deduction, angle C, this is our side C. Okay? Now I could have called any side ABC. I just had to make sure the corresponding angle was the opposite of that side in order to set this up. So what this means is I'm going to rewrite it in color. Sine of angle A divided by side A. You know what we'll do? I'm going to set this up nicely. Put our equal signs here. It says that it's also equal to the sine of angle B divided by side B, which is equal to the sine of angle C divided by side C. Okay? So in order to set up this triangle, you need to know how to plug numbers in to the triangle properly. Example 1. It says that a bicycle path forms a 66-degree angle with one lock of a canal. Okay? Luckily, they're giving us a picture in this question. So I'll read the question and then draw the diagram. At a distance of 2.5 kilometers along the bicycle path, the angle separating this lock from the next lock is 52 degrees. How far apart are the two locks to the nearest tenth of a kilometer? So, this is what they've created. We have our first lock and our second lock. Locks hold water in and change heights of something. Okay, so let's say here's our canal. Lock 1, lock 2. It says there's a bicycle path. We'll call this the bicycle path. That is 2.5 kilometers long. It says the bicycle path forms an angle with the first lock. That is 66 degrees. And then it says the angle from the end of the bicycle path, so let's say this is the end of it, to the next lock is 52 degrees. So they mean this angle here to the next lock is 52 degrees. Okay. So you can see we've created a triangle here. The question is asking us how long the canal is. So we need to find out that side of the triangle. What I'm going to do is I'm going to redraw the triangle without the locks. And it looks roughly something like this. We have a measurement of 2.5 kilometers. We have an angle of 66 degrees and an angle of 52 degrees. Okay? So we're going to bring in our sine law. We have it on the side here. Now, what's important for sine law? This is very important, so I want you guys to pay attention to this part. In order to use this, you need to have a complete ratio. Think of each of these as a ratio. Okay? It's a fraction or a ratio. You need to have one complete set in order to solve for missing sides and angles. So I need to either have angle A and side A, or angle B and side B, or angle C and side C. If I have a complete ratio, I'm not going to be able to set these up to solve. So let's put this together. I'm going to name this triangle. I'm going to say that the 52 degrees is angle A, which means this opposite side is side A. Okay? That's opposite of that angle. I'm going to call 66 degrees angle B, which means this side, which is opposite of it, is side B. Remember, the opposite side is a side that is not adjacent or not touching that angle. And this will be C, which means this is side C. Okay? So what I'm going to do now is I'm going to plug these into sine law. In order to figure this out. So this says sine A, which is my angle. What was the measurement of this angle A? 52. Is 52 degrees. Divided by, do we have the measurement of side A? Nope. So we have side A is equal to, do we have the measurement of angle B? What is it? Yeah. Do we have the measurement of side B? Nope, so we leave the B there. And do we have measurement of angle C? We don't have it. Do we have the measurement of side C? What is it? Good. 2.5. So we're working in kilometers also. Okay. I want you to look at this. Do I have a complete ratio of any of these? No. I have a variable missing here, here, and here. So I'm actually kind of stuck. Is there anything I can do to complete one of these ratios? Nope. Zach, how do I solve for C? Yep, that's right. So this triangle equals 180 degrees, so we can actually solve for angle C. We know that if we take the 180 degrees and we subtract the other two sides, so we subtract 52, and then we subtract 66, this is going to give us what? 128, and then 262. Is that right? You guys got a calculator? You want to check that? Let's check. 180, subtract 52, subtract 66, 62. Perfect. So angle C is 62 degrees. Okay. So what that means is I can now replace this C with 62 degrees. Now I have a complete ratio. So I have this complete ratio. I need to use this ratio against another ratio to solve. Now, I want you guys to look at this. I technically have 3 ratios. We're only going to work with pairs at a time. So what would you guys like to solve for? Side A or B first? A? Okay. So if I'm going to solve for side A, that means I'm going to drop this middle ratio out. I don't need it anymore. I'm just going to work with A and C. So we're going to say we're dropping this off. And I now have sine 52 divided by side A is equal to sine 62 divided by 2.5. Okay? Now, we could solve for this algebraically because I only have one variable. Okay? I could go about dividing and such. Does anyone know a quick way to get rid of the fractions? There's a term for it. Has to do with crossing. Yeah. I have two fractions that are equal to each other. So because I have two equal fractions, I can cross multiply. Okay? If you guys remember that, I was way back in elementary school. I take the bottom of one side, I multiply it over here. And I take the bottom of the other side and multiply it over here. So when we cross multiply, draw our arrows. This will have an A here, and this will have a 2.5 over here. So we'll be getting rid of the bottoms. That's what cross multiplying is. So I'm now left with 2.5 multiplied by sine 52 is equal to sine 62 multiplied by A. Okay. Now the whole point of this is to get A by itself. So how can I get A by itself? What do I need to move? I need to move sine 62, and how do I do that? Yes, good. Because that's multiplied by now, we have to divide. So we divide sine 62 on both sides. I have to divide the entire side by sine 62. Okay? These guys will cancel out. And I'm left with A is equal to 2.5 multiplied by sine 52 divided by sine 62. Now, if you have a calculator that has two lines, you can put this all in one step. I want you guys to practice this. What I'm going to do, you have a calculator like the one I have on the side here. It's not that good. So I'm actually going to have to solve for my sine 52 and sine 62 first. Then I'll do the multiplication and division. So 52 sine 0.788. Now, many of you guys can do this all in one step. I'm completely fine with that. I'm going to take a few steps. 0.788, that's a good rounding here. And sine 62, 0.88, we'll say 3. We'll round it up. Okay? 0.883. Again, because I rounded, I'm going to probably get an answer a little different than what you guys might get if you put everything in properly. So I take my numbers 2.5 times 0.788, and then I divide that. Is this division? Divided by 0.833. Oops. It's all wrong. 2.5 times 0.788 divided by 0.883. I got 2.23. So side A is equal to 2.23 kilometers. Let's take a look at everything we did there. Okay, so we solved for the length of the river. We know it's 2.23 kilometers. That's fine. I want you guys to now realize something. I'm going to move to another page, okay? And what I'm going to do is I'm just going to copy one of the measurements here. We now know that this is 2.23. I'm going to move this to another page here. So, we solved for side A of the triangle. I'm just going to quickly redraw it. Remember, this was the triangle we had. We had named them A, B, and C. We called this angle A. This was angle B, side B, and angle C, side C. We had this measurement. 2.5 kilometers was side C. 2.23 kilometers is side A. 66, 52, and what was this measurement? Anyone remember? 62. Okay, now, in a question I might ask you to solve the entire triangle. What's the distance from block 2 to the end of the bike trail in a straight line? Okay. Can I use Pythagorean's theorem to solve this? Why not? I don't think it's illegal. Probably be wrong, but it's not a right angle triangle. Okay? So because it's not a right angle triangle, we have to set up our sine law again. But I want to show you what you've solved now. You have a little bit more information than you had before going into this. Now remember, we had sine, angle A was 52. Side A is 2.23. Sine angle B was 66. We're going to look for side B. Yes, good. And this is 62 and 2.5. Now, I have two complete ratios. We have the A's and the C's. I just have to match one of them up with B. It doesn't matter which one. We'll get the same answer either way. So what we'll do is we're going to line up the new ratio we have with this side B. So we no longer need this ratio. We can drop it off. We're just going to work with 2. So we have sine 52 divided by 2.23 is equal to sine 66 divided by B. Now, I'm going to do this step in the head. I just showed you guys how to cross multiply. So you guys should hopefully remember how to do that. And then we divide. I'm going to tell you very quickly. The best way to do this right away, I'm going to move the bottom to the top and the top to the bottom. Okay? So sine 66 multiplied by 2.23 and everything divided by what was on the top over here. Sine 52. That's a quick way of doing it, okay? That's the exact same thing. We cross multiplied, and then I divided by sine 52 because it was on the same side as B. Okay? All I did is did it all in one step. We put this into our calculator. Sine 66, 9.13. So 0.913 times 2.23 divided by and sine 52. Oh yeah, we had that from before. Side B is 0.913 times 2.23 divided by 0.788, 2.5. 2.58 kilometers. So we've now discovered side B is 2.58 kilometers in length. Okay? This is the second example we're going to go through. Example 2. This is a V up here. Okay, let's fix that a little. Now, they're asking us to find angle V, so they want us to find this side here. Now, our sine law works with what variables? A, B, and C. Okay. So what we're going to do, I could replace the A, B, and C with T, V, and U. The same idea applies to it. Or I could just rename the entire triangle. Okay. Which I'm going to do in this case. It's completely up to you how you'd like to solve it. I'm going to call this our A, which makes this side A. I'm going to call this our B, which makes this our side B. And I'm going to call this our C, which makes this our side C. Now I'm going to plug them into our sine law. Our sine law says sine of angle A, which is what? 31 degrees. Divided by, what's the measurement of side A? 5.8 centimeters. Sine B, we don't have the measurement of, so leave it as B. Sorry, I'll do that in blue. Divided by, do we have the measurement of our side B? Yeah, 11.1. And finally our C. We don't have anything for C, okay? Okay, so we don't have anything of the C ratio, so clearly I'm just going to drop that off. And I have the measurements to 3 of the variables. I'm going to be looking for, since they said find angle V, whoa, that just so happens to be our angle B. So we're now looking for, according to how I named it, angle B we're going to solve for. So we're going to set up this ratio. We have sine, oops, let's do this in Sine 31 divided by 5.8 is equal to sine B divided by 11.1. Now, I could cross multiply. The only thing is, if I leave sine B on this side by itself, I already have the B almost by itself. So instead of cross multiplying, I'm actually just going to get rid of this 11.1. I'm going to multiply this side by 11.1. It's the same idea as cross multiplying only one side. And I'll show you what I mean by that. Yep, divided by 5.8. Okay. When we bring the 11.1 over, it's multiplied by 11.1. Okay. Now, let's take a look at sine 31 divided by 5.8. That's considered a what? Starts with an F. Word I'm looking for. Fraction. Fraction. That's a fraction. If I need to multiply this, I need to turn 11.1 into a fraction. What's 11.1 as a fraction? Divided by 1. When we multiply fractions, we multiply the top by the top and the bottom by the bottom. So I'm left with 11.1 times sine 31. 5.8 times 1 is 5.8. Same idea as cross multiplying, where I just brought the 11.1 to the top. Okay? Works out the exact same. Now we have that there. I can go about this two ways. I can solve the left side and then solve for B, or I can isolate B. Is B by itself right now? No, it's not. What's still there? How do I move sine to the other side? I invert it, that's right. It becomes sine to negative 1. So, we're going to split this. I'm going to do this two different ways, okay? On the left side, we'll solve one side of the equation and then bring sine over. Okay? So on this one, sine B is equal to 11.1. You can do it either way. You'll still get the same answer. I'm going to write this out twice, just so you guys can see the two different ways to solve this, okay? So, on the left side, I'm going to actually solve for my left side. I'm going to simplify it to one number. So that means I take 31 sine, I multiply by 11.1, then I divide by 5.8, 0.9856. Okay? Sine B equals 0.9856 is a good number. Okay? On this side, what I'm going to do is I'm actually just going to move sine to the other side of the equation. So we end up with sine inverse, and then we have to solve for what's inside of this. Okay? You can write it either way. You'll still get the same answer. Is equal to B. Okay? Now I need to move sine to the other side here, which means we get sine inverse of 0.9856. And we already know what this bracket's going to equate to because we just solved it. So we get sine inverse of the exact same thing on this side. So it doesn't matter what order you do these two in. You're still, as long as you follow them properly, you'll still get the same answer. So sine inverse of that, shift, sine inverse, 80.2. So our angle B, 80.2 degrees. And what function or mode does my calculator have to be in to solve these? Degree.
Second.
Okay? Oh yeah, or second function to find sine inverse. But I have to be in degrees. If I'm in radians, I will not get the right answer. Your homework, page 402, 1, 2, 7, 9, 13, and 20. 20 is an extended, so if you get stuck with it, don't worry too much.